Today we are talking about the substitution method in the article Focus on Factoring. The purpose of the substitution technique is to help students who have difficulties factoring the form ax squared plus bx plus c, because they are most commonly used to see in the form x squared plus dx plus e. Regardless of the size of d, they usually have an easier time factoring this form. So, how can we convert the form ax squared plus bxc to the form x squared plus dx plus e, so that students may have an easier time factoring these more difficult trinomials? Well, we have to substitute and convert the form ax squared plus bx plus c to the form x squared plus dx plus e. But how do we do this?
Right. This is how we're going to apply the substitution technique. Alright, our trinomial that we're given is 5x squared minus 22x plus 21. We're going to rewrite this to produce a perfect square for the leading coefficient, which is 5. So we're going to multiply the trinomial by the a value, which in our case is 5. So here we are multiplying the 5 across our trinomial. We get 5 squared x squared minus 5 times 22x plus 105. And grouping this together, we get 5x quantity squared minus 22 times 5x plus 105, since 5 times 21 is 105. Alright, step 2, we're going to substitute z in for 5x. So now z squared, the trinomial will be z squared minus 22z plus 105, since we're substituting z in for that 5x. And this effectively reduces our trinomial to the form of x squared plus dx plus e. Now we're going to factor our new trinomial into this factored form, z minus 15 times z minus 7, where 15 and 7, or negative 15 and negative 7, multiplied together equal 105, and sum together is negative 22. By continuing our substitution method, step 4 says that we substitute 5x back in for z. So we have our factored form z minus 15 times z minus 7, and substituting the 5x back in simply is 5x minus 15 times 5x minus 7. Step 5, we're going to factor the greatest common factor, the GCF of each binomial. So our first one, it will be 5 times x minus 3, and then our second one, since 5 and 7 are both prime, we can't get a greatest common factor. Alright, and our final step, step 6, says, since we multiplied our original trinomial, 5x squared minus 22x plus 21 by 5, we made it a perfect square, as in here. So now we can divide out the a value, which is 5. So we're going to divide out this a value and get our final result of x minus 3 times 5x.
Another way that we can view the substitution technique is to get our trinomial, 5x squared minus 22x plus 21. And we multiply it by the multiplicative identity of 1, which is 5 over 5, which gives us the perfect square of the a value. We then distribute the 5, which gives us 5x quantity squared minus 22 times 5x plus 105, which we saw previously, all over 5. You'll notice that we are keeping the denominator of 5. We then substitute z in for 5x, which is z squared minus 22z plus 105 in the numerator, all divided by 5. And we factor the numerator into z minus 15 and z minus 7 as seen previously. Continuing to notice that we keep it all over the denominator of 5. We then substitute 5x back in for z, which gives us the numerator of 5x minus 15 times 5x minus 7. And once again, we find the greatest common factor of the numerator, which is 5 times x minus 3 times 5x minus 7. We then pull the multiplicative identity back out, which is 5 over 5, which is equal to 1. And that gives us the factor x minus 3 times 5x minus 7. Notice how we kept the 5 denominator all the way through. In the previous process, we sort of left off the 5 until the very end. In this method, you can see that the 5 denominator is there through the